morning, class. I am sorry that I cannot be there today. Ivan is sick with pneumonia and an ear infection. We have been up pretty much all night, so we're tired. I'm recording this pretty early in the morning. So what we're gonna do today, we're gonna start with our bell work. As per usual, I'm gonna give you about 5-10 minutes or so to complete your bell work, and then we're gonna talk through some notes. And then there's a reading passage that I'm going to read to you, and then we'll answer the questions. So first, start by doing the bell work. So this is today's bell work right here. Write the steps to sweep the floor. Go ahead and pause the video for 5-10 minutes that is needed to complete bell work. And whenever the students are done with their bell work, have them come grab the notes from either the sub or the aide if they are in the room. They should be on my desk. Take a moment and pause the video, please. Okay, now that we are done with our bell work, we're going to start with our notes. Everybody should have the forces notes, fill in blank notes from off of my desk. If we do not, make sure we go grab them now. Now we're going to start with loading. So we're going to talk about forces today. We just finished our mini flip book that went over 7 of the forces that we have that are applied upon us at all times, and or that we can apply to objects or things in this world. So that was a good little introduction to the forces unit that we are now going to be getting into. So there's all different kinds of forces. No matter what we're doing, where we're at, we have forces acting upon us. It's just whether we realize that they are there or not. So first, I want to talk about what is a force. A force is any push or pull exerted on an object. So anything that you can push, pull, manipulate, that is a type of force. They can be stuff that you do, or it can even be things like gravity that we have no control over, but it is a force that is put upon us. Oh, my bad. Medicine for Ivan. Sorry. We'll do that in just a second. I'm going to pause the video so I can go take care of that. Okay, sorry about that, guys. I had to go take care of Ivan. All right, so like I was saying, a force is any push or pull exerted on an object. There we go. So, how do forces relate to the game of tug of war? So this is one that I'm sure a lot of you wrote about in your mini flip book when it came to tension. If we think about tug of war, everybody is holding you. I mean, you have a group of people on each end and we're pulling, right? That is a type of force. We are trying to overpower the other side through force. We're pulling on that rope, we're causing tension, things like that. So just kind of think about the just mundane things that we can do in life and how forces can affect or play a role in things like just games that we play or you sitting right in your desk. So, facts about forces. Forces are the cause of acceleration or a change in an object's velocity. So we've talked about velocity and acceleration quite extensively over the past couple weeks. So when you apply a force on an object, you are essentially changing their velocity. You are either speeding it up or you're slowing it down in one way or another, depending on the type of force. So the little example there says when you hit a baseball, a force is applied to the ball to make it move. So he is hitting it with his baseball bat, and that hitting force, that applied force, then hits the baseball and makes the baseball move in the opposite direction, causing that change in motion or change in velocity. Okay. Force gives an object the energy to move, stop moving, slow down, or change direction. So like I was just talking with that baseball, it was moving at him, at the baseball player, and he was able to hit it and use applied force against the baseball to make it move in a different direction. So another thing is that we would never be able to move or stop without exerting forces on them. So if we did not have gravity, if we did not have the forces that we have in this world, objects would move infinitely. So friction is another good one. As you roll something along the floor, if we didn't have friction, if we didn't have gravity, we didn't have all these forces, that ball would roll forever and ever and ever until either one, somebody stopped it, or something got in its way to stop it. So without forces, there's no way we would be able to move, stop, or do anything in this world. Forces are very important. So just take a moment to ponder. Can you think of an example of a pulling force? Even a pushing force? Like we were just talking about the tension that we have in the game of tug of war. So that's kind of a pulling force. When you go to open a door, it could either be pull or push depending on the type of door. So you might have to grab and pull or push. Those are a couple just examples off the top of my head. And on top of that, can you think of a force that can cause acceleration or deceleration? When you think about it, a force that can cause acceleration, we were just talking about applied force, right? Where you can hit that ball and then it can move it and make it go in a different direction, causing acceleration. Remember, applied force is just you pushing on something. So if a box is sitting there and is not moving, if you put that applied force against it, it will make it accelerate, right? And then on the opposite side of that, if you think about deceleration, I was just talking about friction. Friction is on everything, no matter if you're walking or something's rolling on the ground or it's the tires on your car going down the road. Everything has friction. Friction is just two objects rubbing together, right? So to cause deceleration, friction can cause deceleration. So as something is traveling, if there's no other applied forces or other forces against it, it can decelerate. And then a force that causes an object to stop, or a force that causes an object to change direction, we've already kind of talked about those in all, like just the discussion that we're having. So next that I want to talk about is net force. Net force is the combination of all the forces acting on an object. So that is the air resistance, that is gravity, that is friction, it is all of the forces acting upon an object. And that is referred to as net force. Net force determines whether the velocity of the object will change. And we will talk a little more about that here in just a minute. But if there is unbalanced forces, meaning that one is stronger than the other, that would determine that it would probably be moving or changing the velocity. An object that accelerates in a direction of the net force. So, like I said, we'll talk about it here in a little bit. I will depict these as arrows pointing in different directions, and then whatever direction has the higher number, that would be the direction that the object will be accelerating towards. However, an object won't accelerate if the net force is zero, so meaning that they are balanced forces. And we'll talk more about this here in just a few minutes. So if they're balanced, meaning that all forces are the same or equal, you will not have any form of acceleration or velocity change, anything like that. So a great example is you just sitting right in your desk. You are sitting there, there's nothing, all the forces acting upon you are the same. So you are not moving unless you move yourself, or somebody comes up and puts some type of force against you to move you. So at this point, you sitting in your desk, you are at a net force of zero. All the forces around you are balanced. And like I said, we'll talk about that just here in a minute. So balanced and unbalanced forces. So balanced forces do not change motion. Like I was stating, that is going to be a zero. There, it's the world acting upon you, it's you acting upon the world, and nothing is changing. It's just kind of you are there, and or the object, whatever it may be. So like we have a soccer ball on the slide as a reference. So it's sitting on the ground. So the weight of the ball, the gravity is sitting on the ground, and the ground is also pushing back on it, keeping it in place. However, there's no players kicking it, so it's not rolling, it's not moving, it is just a balance force, and it has a net force of 0 because the forces are equal. Balance forces always cancel each other out, and like I said, the combined force equals 0. And we'll look at some of these problems here in just a few minutes. So unbalanced forces do not cancel out completely, meaning that one force is greater than another. And when a force is greater than another, it will cause it to accelerate one way or another. It may not be a fast acceleration, but it will make it move. And remember, acceleration is just any form of speeding up or slowing down or changing motion. So if opposing forces acting on an object do not have the same strength, they do not cancel each other out completely. And like I said, unbalanced forces cause an object to accelerate, meaning causing some type of motion in a direction. So I have the little arrows at the bottom here. We have the red arrow pointing to the left, saying that it is 5 newtons. Just a little reminder, I know I haven't said this yet, but net force is always going to be measured in newtons. Newtons is the unit for force, and I will make sure that I have this written on the board once I get back. But just so we know, always have labels on our numbers, so when we go to do these, make sure that we are labeling them in newtons. So we have the red arrow pointing to the left, stating that there is 5 newtons of force. And then we have the blue arrow pointing to the right, stating that it has 25 newtons of force. So what that is showing us is that we have a net force of 20 newtons to the right, meaning that the balance was not equal, like we've seen in the previous slide where it equaled 0. In this case, the force, it's looking like a pulling force, pulling away, is stronger to the right. So the object is going to end up moving to the right. Okay, so here are kind of like what our net force questions are going to look like and or be set up. So it's just going to, what is the net force? It's going to have 2 arrows. So we have an arrow pointing to the right with 20 newtons, and then we have an arrow pointing to the left with 10 newtons. In this case, all we have to do is figure out what's the difference. So 20 minus 10 is 10, but what direction are we pointing at? We're pointing to the left, so it's going to be 10 newtons to the left, meaning that the object, the box, whatever it may be, is going to accelerate to the left. And that's what this is saying here, that change. Oh, excuse me. Nope. This is a new problem. So in this case, now we have 10 newtons pointing to the left and we have 10 newtons pointing to the right. What do you think our net force is going to be this time? For anybody that said 0 newtons, you are correct. This is one of those cases where this is a balanced force. They are equaling 0. 10 minus 10 is 0, meaning that there is this object, the box, whatever it may be, is going to have no acceleration because it has a balanced force. So the force is going to equal 0 newtons, and that's it. Alrighty, so now that we are done with that, in our notes, I need us to pause the video for a moment and hand out the reading packet. Should look something like this. So I need you to take a moment and hand that out, give that to the students. And once you get there, I'm going to read through the packet and then we're going to answer the questions. Okay, I hope everybody's got their packets and are ready. Please pay attention because this is going to break down what forces mean and kind of how to work through them. So if you need, you can go ahead and grab a highlighter or you can use your pencil, marker, whatever you need. But take a moment as I'm reading and highlight important things or things that you may think are important. This will be a source that you can use for your tests or just anything that you may need. So the better highlighting, the better note taking. There's a margin on the side there that is for you to take notes. All the better for you in the long run. So if you need, take that moment, grab a highlighter, but I am going to start reading. Okay, so like I said, we're going to talk about forces. It says when you ride a bike, your foot applies a force, pressure, to the pedals, which allows the bike to move. Additionally, if your foot stops applying this force to the pedal, the bike will no longer move. A force is a push or a pull on an object. There are many different examples of forces. When a skydiver jumps from an airplane and opens his parachute, a force, air resistance, is applied to the parachute to keep the skydiver from accelerating so rapidly. Other forces include gravity, friction, and tension. Forces affect how objects move. They cause motion. However, they may also slow, stop, or change the direction of motion of an object that is already moving. Force can affect motion in several ways. For example, when a baseball is thrown by a pitcher, a force causes the baseball to move toward the batter. When the batter strikes the ball with a bat, the force of the bat will cause the ball to change direction. Force can also cause objects to stop moving, move faster, move slower, start moving, move faster, move slower, stop moving, or even change shape. Since force can cause a change in velocity or speed or direction of an object, we can say that forces cause acceleration. Forces are measured in newtons and usually act in pairs. Although forces cannot be seen, their effects can. Have you ever watched a demolition ball knock down a building? A tremendous force is applied that causes buildings to crumble to the ground. We can see the effects of this force. More than one force can act upon an object at a time. The forces can push or pull in any direction. The direction of motion for an object is dependent upon 1. How strong the forces are, and 2. The direction in which the force is applied. So in a game of tug of war, the person who pulls with greater force wins. When more than one force acts upon an object, the forces combine to form a net force. The combination of all forces acting on an object is net force of an object. So here it's showing 30 newtons plus 10 newtons, and they're both pointing to the right, meaning that this has 40 newtons net force to the right. So in that case, they added them together because they were pointing in the same direction. In an example on the previous page, two objects are pushed in the same direction, each with its own applied force. These forces are working together. So the net force is 40 newtons. So these are the forces added together. But forces can also work against one another. This is known as opposing forces or opposite forces. In this example, two objects are applying opposing forces to one another. Thus, the direction of motion is in favor of the greater force, and the net force is found by subtracting the two opposing forces. So here, again, we're showing 30 and 10. However, one is pointing to the right, and one is pointing to the right here, or to the left. Wow, I'm backwards. This one's pointing to the right, and this one's pointing to the left. In that case, it's meaning it would be 30 minus 10 to get 20 newtons of net force to the right. Two or more opposing forces are balance forces if their effects cancel each other out and they do not cause a change in an object's motion. If forces of equal strength act on an object is opposite directions, If forces of equal strength act on an object is opposite directions, the force will cancel resulting in the net force of 0 and no motion. So here again, it's showing the 50 newtons to the right and the 50 newtons to the left. 0 newtons, meaning no motion. This is a balanced force. The two people pushing on the box are putting equal force, meaning that box is not going to move. Okay. If the effects of the forces don't cancel, the forces are then considered unbalanced forces, and the net force then will be greater than 0. Unbalanced forces cause change in motion. So anytime that there's an unbalanced force, the object that it is being applied to is going to have some form of motion. So in this case, we have 45 newtons. He's kicking that soccer ball. And then there's 5 newtons of like air resistance or gravity on this other side, meaning that we got 45 minus 5 to equal 40 newtons to the right, meaning that see that soccer ball is kicking it to the right. So here in the margin notes, describe what is taking place in the illustration below. Be sure to include details about the force acting on the object. Are they balanced or unbalanced? What is the net force? Will the object move? If so, in what direction? So I'm going to give you some time. If we need to, we can pause the video, but I really want you to take that time in the margin notes and write those down. I will be checking on that to make sure. Remember, we're answering, are they balanced or unbalanced? What is that net force? So if they're balanced or unbalanced, we'll be able to figure it out. And if it's unbalanced, then we need to figure out the net force. What would that be and which direction it may be going in? And will that object be moved? Okay, if we need a little more time to write that stuff down, go ahead and pause the video. But I'm going to move on just for the sake of time. So at this point, we are going to be talking about the tasks. This is going to be placed on students. I'm going to be checking on this stuff. If we need to work in groups, we can go right ahead. That is fine. But we have to be working. This is going to be due in a class, whatever we can get through. And then when I get back tomorrow, we can talk through it. But for right now, what I need you to do is I need you to write down vocabulary. So these are things that we talked about either within our notes or within this reading passage. So I just need you to write me down, what does force, newtons, net force, opposing force, balance, or an unbalanced force mean? And then I just need you to list me off 4 examples of forces. They are kind of listed up in the reading, or kind of around. And then how do forces cause acceleration? So I need you to answer that question. And how can forces affect an object's motion? Those were all answered up in the reading. So then task 2, need you to give me an example of a pushing force and a pulling force. These are things that you probably did in your mini flip book. They should either be on my desk or in the bin. So if you want to look back on those, you can. And I also need you to answer, what is the difference between opposing forces and forces working together? So that is asking us, what is the difference between balanced and unbalanced forces? And here we're going to compare and contrast. So what's the difference of unbalanced forces? What's the difference of balanced forces? And then what are the things that they have in common? If we get stuck on this one, that's okay. We can talk more about it when I get back. And then task 3, we are answering these questions about the picture and just about forces in general. So number 1, the forces above are either A or B, pushing force or pulling force. So it looks like they're playing a tug of war game, right? Look at the arrows. The forces above are working together. Opposing forces, the forces above are equal or not equal. The forces above do or do not balance. The net force is 1,000 newtons to the right, 1,000 newtons to the left, or 0. And there is either motion or is there no motion. Number 7, if an object starts to accelerate, a balanced force is acting on it, gravity is acting on it, velocity is acting on it, and unbalanced force is acting on it. Remember the difference. I'm going to kind of cancel. It is not going to be gravity and it's not going to be velocity. So B and C, go ahead and just cross those out. They're not going to be it. It's going to be between A and D. Number 8, a person pushes a box with a force of 6 newtons, the box moves. This is an example. Again, I'm going to tell you it's either between B and C, an unbalanced or a balanced force. This is not going to be inertia or acceleration. So cross off A and D. It's either going to be B or C. When forces are balanced, the net force is greater than 0 newtons, less than 0 newtons, or equal to 0 newtons. Remember, we're looking at balanced on that question. And a person pushes a wall that doesn't move. This is an example of, we're going to go balanced force or unbalanced force. Go ahead and cross off inertia and deceleration. Those are not going to be. So it's between balanced or unbalanced force. And a force is which one of these? A push, a pull, both A and B, or none of the above. Lastly, 12, a force is exerted on a box and an equal and opposite force is exerted on the box. What will happen? So that is saying one person is pushing on the box and an equal force is being pushed in the opposite direction. So what's going to happen to that box? So I need you guys to take the time to answer all those questions. Like I said, if we don't necessarily get through it, that's okay. We can talk through it tomorrow before our notes. If you have any questions, I have asked the sub, ask Miss Nadia. They can either, or whatever aids with you, they can reach out to me and I can get to you, or you can always send me an email. If not, everything should be good. I hope you guys have a great day and I should be seeing you tomorrow. Thank you.